I will start by just a few slides before going into the hands-on. So for the tutorial, so Pyxel, it's a version on GitLab. So if you want to have access to Pyxel, you have to contact the maintainer, which are Matej Arko and Frédéric Lemel. You can contact them on the Discord. They will be happy to lead you to get the access to the GitLab repository. It's still an ongoing process to make it open source, so that's why you can't have access to it directly, but you can still do it by contacting the maintainer. And the documentation is available on the, you can directly check, once you have access, you can directly check on the GitLab, you have a link to the documentation, or you can click on this link. For the communication channel, we have a Gitter that allows you to interact with the maintainer, developers, reporters working on Pyxel. You have the link on this slide. And another thing that you can do is that on the Discord, we created a section on Pyxel, as I highlighted here, where you have several channels, one for the update of the repository. So it's mostly automated updates with a bot. Pyxel resources is important links that we share on this, and Pyxel discussion is, well, when we have some issues that we want to discuss, we usually go on this one. And we have a vocal channel, Pyxel Help, that you can try to connect to if you want to have some help. And if we see you there and we are available, we will try to drop by the vocal channel and help you. For the tutorials, we provide all of the resources. The installation is not mandatory to follow. You can just, first, the simple of us, you can just look at your screen. The other way to do it is either to do the standard installation procedures that's on the documentation, or you can use Binder, as Thibaut said. So you can use the link that Frédéric will be sharing on the Discord, and I think on the chat, that will open the Jupyter notebooks with the tutorial that we will be going through for this session. So now we're finished with the slides. Let's go ahead and try to play a bit with Pyxel. So Matej, I will let you lead the way.
Okay, let me just share my screen. This one. Okay, I think this is it. So, hi everyone, my name is Matej Arko. I'm a young graduate trainee here at ESA, and I've been working on Pyxel since last year. So today and tomorrow, me and Benoit and Frédéric are going to present the Pyxel tutorial or walk you through, just to give you a quick look of what Pyxel can do. So today is more about Pyxel architecture, and tomorrow we will present more detailed examples on the more advanced use cases. So Benoit already told, so you can how you can set up Pyxel.
Can you enlarge a little bit? We cannot
yes,
very well.
Of course, I forgot. Is this good now?
Yes. Yeah.
Okay, I'm gonna rerun. Okay. Yes, I'd like to know maybe, is there any of you that are following the tutorials live and trying to run the tutorials in Binder? Maybe you can raise a hand so we get a quick overview of.
We've got a few people. Yeah.
A few? Okay. Good. Nice. Okay, so let's continue. So the first notebook in the tutorial is just introduction, and we already covered this. There's some useful links here that you can use. The tutorial structure, and also for all the people that are new to Jupyter Lab or Jupyter Notebooks, just to give you a quick introduction. So Jupyter Lab is a web app where you can edit Jupyter Notebooks. These combine code and text into in these cells that you can run. There's a Python kernel running in the background, so you can run Python code live. Here I can do the test check, import Pyxel, and so I see that Pyxel is currently in version 0.10. There's edit mode and command mode, so you can edit cells, input markdown or Python code or just raw text. Okay, so let's move on to the single mode, the first simulation with Pyxel. So in this first notebook, we will see how to load up the configuration file, how to run Pyxel in single mode in Jupyter Notebooks, how to display the final detector object, and how to save the outputs. And also later on, how to edit the YAML file and how to display Python classes, or how to inspect Pyxel classes. Here in the single mode, we will apply a few models to a fits image of Pleiades. We of course start by importing all the necessary functions that need to be used. So we import Pyxel.inputs outputs, which is a module for loading configuration, for example. We import Pyxel.run single mode function from Pyxel.run and function display detector from Pyxel.notebook, where all the nice display functions are stored. So when we import this display detector, we also import HoloViews and bokeh, which are going to be used as plotting backend, and we see those icons here indicating that the import was successful. So first thing that we need to do is load the configuration file, which we see here on the right. And Tigo already told you that it consists of 3 parts. So the first part describes the running mode, the second part the detector, and the third part contains all the model functions and all the arguments of models in this pipeline. So we import this YAML file with function io.load, and what it does, it actually, so this YAML file is read as in this huge dictionary, nested dictionary, and these dictionaries are converted into objects in Pyxel architecture. So each of those 3 parts is converted into a class. So we can access those classes just like this. So we're gonna access single and detector and pipeline objects. And if we see here, so single class contains all the information about outputs. In this case, we specify output folder and what data do we want to save. In this case, detector, we're going to access the image and the pixel arrays, and we're going to save them in fits and numpy files. So in the next part, we specify all the properties of the detector. This is geometry, material, environment, and characteristics. I'm gonna get back to it. And the next is the pipeline. So we run the pipeline by calling the function single mode, which I can. And so you will see. So once we run the single mode function, we have to pass all these 3 main objects into the function. And once we do that, the detector object that gets created in the beginning passes through the pipeline, and models get applied to all the data that is stored in the detector object. So in the beginning, the detector object is empty. It's constructed from this one. from this part of the YAML file. It only contains information about geometry and so on. So we can specify the size of the detector, the thickness, material, temperature, for example. And once it passes through the pipeline, we can go one by one. This data arrays get populated. For example, in the first model group, so all the models are grouped into model groups. Each model group describes a certain part of the detection process. For example, here the first model group is photon generation. And here we populate the photon array with the load image function. Well, what it does is it loads the fits file of Pleiades. It also fits image to the detector size, and we also apply some shot noise. In the next part, we apply the optical point spread function. So here we use poppy. And also in this model group, we also align. We take care of shape of detector and input image. So if we move on, so now we populated the photon array, and we create charge from this. Charge is a pandas data frame which contains a 3D point cloud of the charge. We convert photons to charge, and then in the next one, so we apply cosmic ray model. This is stars, and so on. So in each model groups, this data gets changed. We also populate pixel, signal, and image. Here, maybe one important model is also CDM for CTI. Here we specify that we would like to apply one trap species with density of 20, and so on. Yeah, so in the end, what we get is a detector with populated data with all the models applied. So in the end, we also applied some readout electronics, and we can display detector with function display detector, which is going to display all the arrays except for charge, because it's a pandas data frame and it's a 3D point cloud, so we can display it that nicely. We can see that here we can display the input image. So the photon was when we applied PSF and shot noise, so we can see it's a bit blurrier because of the point spread function. So in the pixel stage, this was after CTI and cosmic rays. Here we see the trails of cosmic rays, and also the smearing due to CTI in the stars, and so on. So we can display all the 5 different arrays that were stored in the detector object. And because we specified here in the beginning that we would like to save the image array and pixel array into fits and numpy in the output directory output, if we check here, we can check output the last run. We also get the numpy and fits file of our specified outputs. Okay.
That does work.
Sorry?
This part does work. We can see the detector.
Oh, so it didn't break completely. Okay. Yes, so I think this is all for this simple single mode. So in the end, we get the image. You can download the fits file, observe it in DS9 or so. Maybe a note here. So what properties can we put into detector? So you can check in the documentation. The CCD detector can also be CMOS. And then pipeline is a bit different because we get signal transfer here. And if we observe a bit closer, so each of the model functions that are grouped in model groups has certain arguments. And just a note, so all the arguments that are common to multiple models and used by multiple models are stored in the detector object as properties of the detector, usually, if it's not specific to the model, and if it describes a property of the detector. So this is the so all the arguments that can be used by multiple models are then stored in the end in the detector. We're also working on saving the detector in HDF5. And yeah, this single object here is quite simple, but it gets more complex with parametric and calibration mode. I have another notebook here, so 02, where I describe more, a bit more in detail how do Pyxel classes look like and how we can change the YAML file. So I'm gonna also show this one. There's this useful function display HTML in Pyxel.notebook that we can use, and I'm going to do this live now. We import display HTML from Pyxel.notebook and IO again from Pyxel inputs outputs to load the same configuration file. And a note on YAML syntax. So what inputs can we put into YAML? We can put numbers, for example, floats, integers, scientific notation. We can input strings like this, or forced string like this. Lists look like regular lists or with bullet points. And also dictionaries can be put in YAML in different ways. So this is a dictionary, or at least this is the same as this dictionary. So basically, when we read YAML file, it's a huge cluster of dictionaries, lists, numbers, and strings. You can also put comments into YAML file. And for example, this part of YAML code would be converted to a dictionary with keys foo and bar, so this top level. And once we go down, we get a list 1, 2 here, and another dictionary which is nested with keys 1 and 2, and so on. So these are used then to construct our Pyxel classes.
Can I ask something?
Yes.
Do you actually need the YAML file, or can you pass the dictionary directly? So you create the dictionary on the fly, and do you then need to write it to a YAML file first, or can you just use that as is?
I think if you use some functions from Pyxel core, really, that you could input dictionary, but you would have to work around a bit.
Yeah, you don't have an easy way to do it.
But
you could do it, but that's something that we could implement, of course.
But the point of YAML files was that it's easy to read, of course, much easier than dictionary. So this is why this is the main input. Okay, so we use this display HTML to inspect then the classes that we load into Pyxel. If we look at the config object, so this is how it looks. It's just a table of attributes, the data type of attributes, and what is the value. So here, once we load the config, we assign the attributes single and CCD detector and pipeline. And other options would be CMOS detector and parametric calibration and dynamic. So this is an instance of a single class. CCD detector is instance of CCD, and this is a detection pipeline. So we can access those attributes like same as before. And now we can take a look of how these classes look like more in detail. So if we display HTML on single, it contains the attribute single outputs, or outputs, which is an instance of single outputs class. And maybe I can show this. So single dot outputs we can also see with display HTML, and we see that there's a logger in that. There's output directory and save data files. So it mimics completely the structure of YAML file, how it looks, the architecture behind. And the detector, it has these 4 parts: geometry, material, environment, and characteristics. This is the only thing that we see in the YAML file, but actually there's much more behind. So if we use display HTML on detector, we see there's a lot more attributes stored in the detector. For example, we have arrays like photon and pixel signal image, also the pandas data frame, the discharge, and a bunch of attributes that are needed for dynamic mode, for temporal simulations. In the beginning, when the detector is empty, there's no photon assigned, and all the others, I think, are just 0. And once we assign the photon, we can, we can use it for converting to other arrays. Geometry is an instance of CCD geometry, and so on. So material is material. And other similar. Okay, so the last one is pipeline. If we use display HTML on pipeline, we can see that it consists of multiple model groups, each with a name. Of course, we saw this multiple times now. Each model group has different models, or a list of models that are applied at that stage of the pipeline. For example, charge collection has simple collection and provable capacity. Okay, and one thing that should be mentioned, so at each model group, it's stated what array does this part of the pipeline edit. So here we create the photon. Here we still are editing the photon array. Here we're converting to charge and charge generation, of course. And then here we assign this charge to a nearby pixel with simple collection. So we populate the pixel array and so on. Okay, so now I have some exercises down here that you can try. So the first one is to use the display HTML function on instances of model group or model function classes. So we can access instance of a model group just by typing pipeline.charge transfer, and if we want to get an instance of model function, then we can type, for example, pipeline.charge transfer.cdm. So we go all the way from the main object to the model group to the model function, for example, shot noise. So this would be pipeline.photogeneration.shotnoise. And then we use the display HTML on these functions. And I'm just going to wait a bit if we have people following on Binder.
I don't have these exercises on my local checkout.
Yeah, there should be there. At least on Binder. Okay.
Okay, I'll try that.
Anyways. So the solution would be just to display HTML pipeline.charge transfer, and if we display this, we're going to see all the models that are stored in this model group. So this is CDM, it has data type of model function. We can see the arguments here and all the models. And if we go one one level below. So we use display HTML on a model function. Then we get all the arguments of the model, so we can actually inspect what we are changing. So the purpose of this is also to change, so you can also change, if you need to change model parameters on the fly from Jupyter notebooks that you can actually access. Like you can type pipeline.charge_transfer.cdm.arguments, and let's say we would like to change. So here the beta parameter is 0.3, so let's say we want to change it to 0.4. Of course, there's no like this, and then we can use this function again. So now we change the beta parameter, and we can use this object in the pipeline then. And the next one is to try change some parameters here and reload the configuration and rerun single mode with the change parameters, and then we can observe the change in display detector function. So I'm just gonna change a few things. For example, I'm gonna use non-squared detector. I'm going to turn off the TARS model. For example, I'm going to ramp up the density of traps. So we're going to see more CTI. And if I want to run the pipeline now, okay, I need from Pyxel.run, I need the single mode function again. I need the display detector function like in the first notebook. I have to load the configuration file. So this is basically the whole program. I load up all the three main objects from the YAML configuration, and I run the single mode and display detector in the end. If I do that, of course, I have to save the YAML file before I do that. So now we still had the TARS model running, and this is without the TARS model now. So, and the detector is not a square anymore, and we should have more CTI here because the density of traps is now higher. And we can also observe the histogram of the image here in the next tab. Okay, I think this was the basic example. Sorry about the errors on binder. I'm gonna check it straight away. What was the problem? And try to run it myself. I think that's all from my side for now. And tomorrow we will see how to use the parametric and calibration and dynamic mode. And with that, I give the floor to Benoit.
Thank you, Matej. Can you stop sharing?
Yes, where do I do that? Stop presenting, okay.
Thank you. So, this one. Okay, so we are going to the third tutorial, which is how to create a model with Pyxel. Does everyone see my screen?
Yeah.
Yes?
Yes.
Thank you. So you have here my web browser where I'm opening Jupyter Lab as well. So I'm opening tutorial 03, create model. I need to open the new model.yaml file in order to make quick modification. So I start with the basic where, so this is some magic command that allows me to not rerun the kernel when I make modification in my function. So don't really worry about this. Then I have the imports. I'm running in single mode as well, using the display HTML and display detector for displaying the information of the pipeline and the detector once it's generated. So when you want to create a new model, the previous way was to try to go into the source code and well, create your Python file, try to do it yourself. So now we have a template which is located in Pyxel templates, and we have a function on Pyxel which allows you to take this template and generate a model that will be in the correct boxes. So you have to remember before creating a model what exactly you want to do, because as Matej explained it before, if you want to work on the photon array, so it's a 2D NumPy array. If you want to work on the pixel, signal, on image, all are 2D NumPy array. But if you want to work on the charge, on the 3D distribution of the charges inside the detector, this one is a pandas data frame. So you would have to be careful when you want to work with this one. And, yeah. My pipeline would be exactly the same as how Matej was doing. So I would be going through optics, charge generation, charge collection, signal transfer, readout electronics in order to fill my different array. So first I use the method in Pyxel, which allows me to create a new model. So if you are working on command line, you can use this. And on Jupyter Notebooks, if you had an exclamation mark right at the beginning, you can use some command of some command line command. So you run Pyxel, you run the -cm, which is -create model, and you want to create it in photon generation, a new model. So photon generation is somewhere here, right? So I want to create a new model here. Poof. And if I take a look at my Pyxel distribution here, yes, module new created. So if I take a look, so this is the source code of Pyxel. You go to Pyxel, Pyxel, models, photon generation, where I wanted to have it. And here, in addition to the previous model that we saw on the photon generation, I have this new model. This is the one that I wanted to create. So if I take a look at new model, so I have to open it. So this is the template docstring that populates the Python script when it's auto-generated. And you have a basic model here, which does nothing. So you have the docstring, which is actually correct in this case. So it's taking a detector, it's CCD, it's taking 3 arguments. So a string, a Boolean, and an integer, but it's doing nothing. Okay. So if you take a look at the docstring, automatically it generated how you should put it inside of the YAML configuration file. So line 83 to 91. So I just have to copy this, go into my configuration file, which is new model.yaml. I go to my photon generation, which is here. Up, and I insert it. So up, I don't need this. Right. So this is my new model located in photon generation model. It's enabled. It's using a string, which is a path to a file, but I will not use it. A Boolean, which is arg2, and an integer, which is arg3. Okay. So now I save it. So if I take a look at the rest, so yes, a small addition, if you have the latest version, this is not in the actual notebook because I forgot it. That here in the init file, which is here, you actually have to put this, otherwise it doesn't find the model. This will be done automatically once I correct it. So once I modified my init.py file, I can use my YAML configuration file to create the pipeline, the detector, and the mode, right? So if I take a look at the pipeline now, take a look at photon generation, model group. It's got load image and new model, which is the one that I was that I created. So, but now this model does nothing. So now let's run the pipeline with a default configuration file to see that it's working at least like this. Okay, single mode with some cosmic rays. Good. So now I'm using the display detector function in order to examine what's inside of the detector after generation. So this is the input file. Then I have the photon array. Then I have the pixel array, the signal, and the image. So you can see some cosmic traces here. What's important is that we want to work on the photon array. So if I take a look at the histogram, the photon array right now is around 600 counts, right? And so now we want to use a new model that I generated and modify a parameter to do actually something on the detector object when we execute the pipeline. So I will say, as I say here, you just have to go to your model. So here I'm doing nothing, everything is commented. So what I want to do is I want to take the photon array, I want to multiply it by the third argument, which is an integer. Okay. By default, it would be 42 if I don't provide anything, but on my configuration file, this argument, I will set it to 2. Everything. Yes, and I save here, and then I reload my configuration file because I changed something, right? And I re-execute my pipeline. So exactly the same as before, and then I display my detector again. Okay, so if you take a look at the input, nothing changed compared to the previous one. So if I take a look at the input image, okay, so spike at 5,500, 5,500. So if I take a look at the photon now, which I should have multiplied by 2, you see that now the histogram spike at 1,200, which is twice the previous amount. So now this is the end of this tutorial. You have created a new model using a command included in Pyxel. On this new model here, you accessed the detector array, the detector object. You try to modify the photon array by just multiplying it by an integer, which is arg3. And if you take a look at your pipeline, this is what was done, is that I just modified arg3. Of course, arg2 and arg1 are still doing nothing, but you could say, okay, I'm using arg1 to open a new file to add it to my photon array, for example. You could do whatever you want, basically. That's it. And so the goal of trying to simplify the way to create models is to well, be able to have more people contributing to this, or at least people find a use to create a custom model. So what's important is that if you want to contribute to Pyxel, you would have to follow the contribution guide. I did put the link on the tutorial. It will lead you there, where Frédéric did list everything that you need to do in order to contribute, meaning what do you need to do when you create a new functionality, a new model inside of Pyxel before trying to put it, to merge it to the master brain that we have, for example. And so this is all of the steps that we need to follow each time we want to merge it with the latest version of Pyxel. Of course, it doesn't prevent you to do your own model and play around, but if you want to contribute to it, you have to follow a certain set of guidelines, which is why Frédéric made this contribution guide here. Okay, so I think that's it.